Welcome to Trigonometric graphs, where we'll look at calculating the amplitude, period, phase and mean value, as well as definitions. So the mean position is the average of the highest and lowest points on our wave. Our amplitude, represented by a little a, is the maximum height of the wave above its mean position. And the period is the length of the trigonometric function to repeat itself. So let's have a look at our basic graphs that we've learnt when we were in year 11. So we've got the sine curve. It starts at 0, 0. At pi, it comes back to 0. And at 2 pi, it returns back to 0 and starts again. So notice that it takes 2 pi for it to repeat itself. So that's the period. The amplitude is the height. So the max height is 1 because that's 1 above the mean value, which is the middle, 0. And the mean position is 0. The cos curve, so similar to the sine curve, its period is 2 pi because it starts at 1. So that's when x is 0. And it returns to 1 at 2 pi. So that gives us our period. The amplitude is 1 and the mean position is 0. For our tan curve, its amplitude is infinity because it just keeps on going all the way up to positive infinity and down to negative infinity. It does have a mean value of 0 because that's the middle. And obviously if we translate this up or down, the middle would obviously change. You will notice that it's got amplitudes at pi on 2 and 3 pi on 2, or hopefully you remember that. And you'll notice that it starts at 0, 0, and the next time it starts at 0 is at pi. So its period is pi. So when we look at the amplitude, or a vertical dilation, as we've talked about in past videos, it's the value in front of the sine and the cos. So it's the a, or the number in front of the sine and cos. And that's our amplitude. For tan, it's fairly obvious that if tan has an amplitude of infinity, then putting a number in front is going to continue to make it infinity. So let's sketch, as an example, 3 cos x. Notice that the 3 is in front, so that's going to be our amplitude. So we're going to have a normal cos curve starting at 3, or the maximum being 3 and the minimum 3. So you can see our normal cos curve, we start at 3. Its period is 2 pi, so next time it repeats itself is also at 3 at 2 pi, and it's got that amplitude of 3. A horizontal dilation, so moving something across the x-axis. We call this the period when we talk about trig curves. So for sine nx and cos nx, so the value in front of the x, the period is 2 pi over the n value. And for tan, it's pi over the n value. So that's the effect that it has across the horizontal. So we're going to find the period and sketch each function for sine 2x and tan x on 4. So let's start with sine 2x. So the period is 2 pi on the n, which in this case is 2. So 2 pi on 2 is pi. So that means that the sine curve repeats itself now after pi. So that's a dilation that's actually condensed it. So our 0, 0 is our first point, and it repeats itself after pi. Notice that I've made that the emphasis. So you'll see a repetition. The amplitude for this one is still 1, but it repeats itself after pi. For tan x on 4, this you've got to be careful of. So remember, x on 4 is the same as a quarter x. So the period is pi on n, and since n is a quarter, that's pi on a quarter, which is 4 pi. So that means that our tan curve is going to repeat itself after 4 pi. So you can see our tan curve starts at 0, 0. It repeats itself after 4 pi. So that means that our asymptote is halfway. And so halfway between 0 and 4 pi is 2 pi. Horizontal translations and phase. So phase is the translation horizontally for any trig graph. So we've done a lot of work on this when we did translation of graphs, shifting a graph along the x-axis left or right. So for sine x plus b, cos x plus b and tan x plus b, they all have a phase b. That is, they've all been moved b units to the left. So we're going to state the phase of each function, and then we're also going to sketch them. So the first one is sine of x plus pi on 2. So we know that with x plus pi on 2, we could always solve that bracket equal to 0, and we would get x equals minus pi on 2, which means it's a left pi on 2. So that's our usual, but the phase is the plus value that's in there, so the phase is pi on 2, meaning the sine curve's translated pi on 2 units to the left. Now, if we move the sine curve pi on 2, and we should remember our complementary angles, we get the cos curve. So everything's been shuffled pi on 2 to the left, and so we end up, as I said, with the cos curve. For the cos x minus pi on 3, so the phase is the minus pi on 3, so that's what's after the x. And the translation, if I let that x minus pi on 3 equal to 0, then I get x equals pi on 3. That is a translation of pi on 3 units to the right. So you can see that where we would normally start at 0, 1, we moved that to pi on 3 to the right. So pi on 3, 1. How do we find all the other values? Well, we could let x equal 0 and we could find where it starts. So cos of 0 plus pi on 3, cos of pi on 3 happens to be a half. So that's how we know that the graph starts at 0, a half. For the other values, they would be solving when y equals to 0. That's where it crosses the y-axis. And we know that the cos curve repeats itself after 2 pi, so we could find the next value and halfway to find the minimum value that it reaches. So now we're going to have a look at everything combined. We're going to find the period, phase, amplitude, and mean value. So one suggestion is focus on everything that happens on the x-axis first, and then work with the y-axis second. And we're going to do this in 4 steps actually. So we're going to do sine of 2x, then we're going to do sine of 2x plus pi, then we're going to introduce the 2 in front for the amplitude, then we're going to subtract the 1. So we're going to move everything along the x-axis first. So step 1, sine of 2x. So the period is 2 pi on 2, so that's a period of pi. That means that the sine curve repeats itself after pi. So here's our example. So you can see the sine curve has repeated itself after pi. So the next thing, to find the phase, we need a single x value inside the brackets. So we've got x plus pi on 2. That means the phase is pi on 2. So therefore, that means it's been shifted pi on 2 to the left. Now, when we did translations, this would have been the same as solving that original bracket, 2x plus pi equal to 0. You would have minus the pi and divided by the 2, which is minus pi on 2, and we would have shifted it to the left pi on 2 anyway. So this is the curve, sine 2x curve, remember, that has been shifted pi on 2 to the left. Now let's introduce the amplitude. So we're going to take that last curve and just increase the height. So the max height will now be 2 and the minimum height will be minus 2. So it's the exact same curve that we've just drawn, only we go up to 2 and down to minus 2. And then we do add the minus 1 on the end, so that's a translation down 1. So our maximum height on the last one was 2 and minus 2. So when I translate down 2, the max height now goes from 2 to 1. The minimum height goes from minus 2 to minus 3. And that means my mean value, which is the average of those, or the middle of the graph, is at minus 1, because I shuffled it down 1 from 0 to -1. And that is our curve. Now, you may be asked for harder examples to find the where it crosses the x-axis. And of course, that is where we would let y equal to 0. But that would be a difficult example, and there would be extra marks involved for that. Thank you.